Page 20, the kinematics equations, part 1. We're probably actually going to be spending 2 days on part 1. And in a few minutes, you'll understand what distinguishes part 1 from part 2. Part 2 elevates it to a higher level. Part 1 is a little simpler. We're going to be solving uniform acceleration problems using what I call the kinematics equations. And it's really important you understand everything we're doing over the next probably close to a week deals with uniform acceleration. So that is like the example that we just did, that Sophia had asked about, where we had a velocity time graph, but it was a constant slope. So that means a uniform acceleration. Before we get to what's in your handout, what we're talking about here is solving problems where the graph of the motion can be written this way. We're talking about situations where there's an initial velocity and a final velocity, and there's also a time. Now, I hope you understand that if I have an object moving with an initial velocity, and this is not in your notes, this is just me up here. If I have an object moving with uniform acceleration, that means it has a velocity to begin with, it has some final velocity, and it happened over a period of time. I hope that everybody understands there's an acceleration, right? And if you use the definition of acceleration by taking rise over run, or what we just talked about actually, you end up with, I know your formula sheet says delta V over delta T, but I prefer to say you end up with VF minus VI over T, right? So this is called a kinematics formula. It is a formula that relates velocity initial, velocity final, time, and acceleration together. Are there other mathematical relationships between the quantities? Well, just a second here. Would you agree as well that there is a displacement that has to take place? That you can't have an object moving without it changing position. So we can come up with another equation that has displacement in it because we know this area is the displacement. And the area of this rectangle at the bottom is the product of the length and the width. Are you with me on that? That the length is t and the width or the height is vi. And we know that this is 1/2 the base times the height which would be that. You with me? So if I take 1/2 times the height, which is VF minus VI, times the time, which is the length, I get the area of that. What that means, everybody, is that the displacement of this object will be VIT plus 1/2 times T times VF minus VI. Are you with me still? We're using things we've learned. You're not expected in this course to derive what I'm about to derive, okay? But I also want to treat you as a Physics 20 student. And many of you will go on to post-secondary and take physics where you might be required to do this. Now, I know, look up here, I know that acceleration is VF minus VI over T. If I multiply both sides of this equation in the red cloud by T, I get this equivalent statement. I get A times T equals VF minus VI. Right? Mathematically. But VF minus VI is right here. So I'm playing mathematical games here. I'm doing some algebra. I could put, instead of the VF minus VI, I could write A times T. and get d, the displacement, of any object, if it's uniformly accelerating, will be the initial velocity times the time plus 1/2 times the time times the acceleration times the time. Because the acceleration times the time is the same as Vf minus Vi. And nobody in any kind of academic setting would write 1/2 times t times a times t. What you would do is write this as 1/2 at squared. You will notice, I hope, that I'm being very careful about things that are vectors. I'm putting those vector symbols above. So, now, let's just pause for a second, because this, you can either be writing this down or not. I think it's better for most of you if you just sit back and are thinking about this. Now what I have is I have, and I forgot to write squared here. I believe I said squared, but I forgot to write squared. What I have is this equation that we have developed, bless you, and I have this equation, which we've kind of developed, but it's just really a formula based on a definition. So I have an equation in the top right corner that connects A, Vf, Vi, and T. And I have an equation down here that connects D, Vi, T, and A. Do you see that this equation in the top right doesn't make any reference to D? And this equation in the bottom right doesn't make any reference to Vf. So the equation in the top right is used when we're not interested in D at all. The equation in the bottom left is used whenever we don't have any desire to know anything about Vf. So you might use this top equation if you know the acceleration, the time, and the initial velocity, and want to determine the final velocity. You might use this bottom equation if you know the displacement and the time and the acceleration, and maybe want to find the initial velocity. They're tools. Okay? So now, let's get to the formal part of the lesson. Based on the definitions that we have learned, you can continue to do what I've done and create more formulas. Okay? Just based on the definitions, you can create more formulas, and if you use the algebra correctly, the formulas must be true. And these are the formulas. Okay, so let's not worry about your formula sheet for a second. Let's look at what's up here. Again, I prefer to use A equals Vf minus Vi over T. Okay? But I want you to, maybe I will write that down just so we can see it. Do I have it there? No, I don't. Maybe I'll just write this down so we can see it. So this formula that I've written in red replaces what's above it. We don't have to worry about what's above it. And that means that we have 5 kinematics formulas, right? Let me indicate them. We have 1, 2, 3, 4, 5, right? These are what I call the 5 kinematics formulas. How many kinematics descriptors are there? How many variables are there when we talk about accelerated motion? There's time, there's initial velocity, final velocity, displacement, and acceleration. There's 5. And if you look at each of these formulas carefully, each formula has 4 of the 5. The first formula, bear with me, this is a lot to hear. The first formula has Vi, Vf, A, and T, and is missing D. The formula below it has D, Vi, A, and T, but it doesn't have Vf. Knowing what the equation doesn't have is helpful. Okay? This equation smack dab in the middle of the screen is missing the time, but it has both v's and the acceleration and displacement. This weirdish looking one up here is missing the acceleration but has everything else, and this one down here is missing vi. By the way, just so you know, you can make a mental note. This one in the bottom right is very rarely used. Very rarely used. You might go through the whole unit and use it only once. Okay? Now let's talk about your formula sheet. So get your formula sheet out, please. And there, it's a little blurry, there is a clipping of the formula sheet. So first of all, there's more under kinematics, right? There's just the first layer. We're doing a lot more. But the first thing to note is that, and I don't want you to cross anything out, but we're not using the velocity formula when we talk about this stuff. You might, the odd kinematics question that has uniform acceleration, you might be asked what's the average velocity, in which case you could go back to that formula. But these are the 5 formulas, right? Secondly, you know, of course, that until you're told otherwise, we don't need to concern ourselves with an average for acceleration. And I think it's better to always think of this as Vf minus Vi over t. But there's an error on your formula sheet, and I brought it to the attention of people at Alberta Education before, and we've had healthy discussions about it, and we disagree. Okay? On your formula sheet, there are no vector symbols over the A and D in this formula. And I'm going to just say it. That's wrong. That is wrong. If you don't include those vector symbols, there are going to be physics problems that you do that you will get the incorrect answer. Okay? And Alberta Ed recognizes what I'm saying is true, but they take a different approach in how they're teaching students to solve problems with that formula. Okay? They need to be there, though, from my perspective. And you will never be penalized for using them, but if you don't use them, you're going to get questions wrong. You will. Okay? So make that correction on your formula sheet. And if you like, you can draw in that Vf minus Vi over t is maybe the better way to look at this for acceleration. The final thing I want to say before we try some of these problems is this. In every situation where you have accelerated motion, if there is something you want to find, maybe displacement, or maybe the acceleration, or maybe the final speed, or whatever, it's physically impossible to find that thing unless you know 3 other things. If I tell you the initial and final speeds and say, what's the acceleration? That doesn't make any sense because you don't know how long it takes. You always need to know 3 things to find a 4th, which means of the 5 things, there's going to be one that you really don't care about. In every problem, there are going to be 3 quantities of Vi, Vf, Ad, and T. There's going to be 3 of them that you know, and 1 that you were asked to find, and a 5th that you don't care about. And it's that identification of the one you don't care about that leads you to the equation to use. If you don't care about A, then you're going to use this formula because it doesn't have A. Right? If you don't know A and you don't want to find A, why would you use a formula that has A in it? All right. So, D is the displacement, A is the acceleration, Vi is the initial velocity, Vf is the final velocity, and T is the time. Time, of course, is a scalar. Now, I just mentioned that you need to be careful about things that are vectors. What makes today's lesson simpler is, it turns out every problem we do today, we don't have to worry about vectors. Okay? Let me explain why. All the formulas are capable of handling directions. So if a velocity is negative and the other velocity is positive, you put in a negative and a positive. If the displacement is negative because it moved to the left, you put in a negative for the displacement. But that only becomes important if the object changes direction. If the object is always traveling the same way and it's accelerating in that direction, we don't need to worry about negatives. So in all of the examples we complete today, the direction of the acceleration will be in the same direction as its motion, so there's no need for negative. Everything's going to be positive today, and either tomorrow or Friday, things are going to change. All right? The directions in the formulas will become important starting in the next lesson. So here we go. Number one, an object accelerates at a certain speed, or acceleration rather, 3.95 meters per second squared. It reaches a final speed of 34.2 meters per second after 3.01 seconds. What's the initial speed? So let's make a list of what you know. I think it's helpful to make an itemized list in these problems until you get used to the formulas. I'm going to leave that as a vector. Okay, I'm going to leave this as a vector, even though I said direction isn't important. And I'll come back to why it's not important in a second. Okay? But I would rather you get used to using vector symbols than not. The final speed is 34.2 meters per second. I mean, right there, you're told it's a final speed, so it's not really a velocity. What we're assuming is it's moving in the same direction as the acceleration. So if the acceleration is positive, so is the velocity. Okay. And you might have a tough time wrapping your head around how it could be otherwise. That the final velocity could be opposite to the acceleration. Well, that's if I'm driving a car and I hit the brakes. The acceleration is backwards. But that's not for today. The time is also given. It's 3.01 seconds. And we are asked for the initial speed, which is really the initial velocity. Since all of these things are in the same direction and they are all positive, time has no direction. I don't really need the vector symbols. So I could drop them if I wanted to. I'm going to leave them in anyway. And here is maybe my thinking. If you always use the proper directions, you will always get the right answer. There are some times where you don't need to include directions, like this, but if you include them anyway, you'll get the right answer. There are cases where you have to do it, so why not do it all the time? So your job right now is to identify in those 5 kinematics formulas which are on your handout or on your formula sheet, which formula to use. It's got to be the formula that has VF, T, A, and the thing we want to find, which means, everybody, that since we don't care about D, you're going to pick the formula that does not have D in it. And that's going to be A equals VF minus VI over T. And here's where, I've said that I would rather you write, just look up here please, I've said that I would rather you write this if you don't care about direction, right? That this that I've written is the same as that. But there comes a time where we can be reasonable with each other and say, I'm just going to write that. It just means I'm not worried about directions because they're not important. So I put the numbers in. And here's where the math isn't difficult. It really isn't. But my experience is, based on the fact that you have 5 formulas, and each formula has 4 things that you can rearrange for, that there are 20 different arrangements or rearrangements. My experience is that at the beginning of grade 11, students don't have a very strong math background in solving equations. So for that reason, let's put in the numbers and not worry about the units. And I'm going to just come right out and ask, So the units, I'm leaving the units out for the simple fact that if I put in the units, it looks more complicated than it needs to look. So I'll just come right out and ask, how many of you know how to rearrange that equation and find out the value of VI? The few kind of nodding, but I sense some hesitation here. And that's because you're not used to, you know, in high school you go into math and you think, okay, that's math, and I leave math and I'm done with math. You should be learning math in high school and applying it to different things. One of the strategies we use in solving an equation is this. We do not want to deal with fractions. Okay? So when you're in my math classes, if I say, well, we're going to have to simplify the equation before we solve it, one of the things that means is we get rid of fractions. And anybody who cross multiplies, you need to stop it at this level. I would say you need to stop cross multiplying in physics and in math. When we do algebra and math, I will mention this. We're not cross multiplying, we're doing something else. We're getting rid of denominators. So there's a denominator here of 3.01. How can I eliminate that denominator? And I'm teaching you something that you would use in other units in this course and other courses. You get rid of that denominator by multiplying the top of this fraction by 3.01, so it will cancel. But that means I have to multiply the other side by 3.01. It's an equation that's in balance. Whatever I do to one side, I do to the other. And I apologize, but I'm going to be teaching you math for a while here, for a couple of days. So what happens is on the left-hand side, you're left with whatever this is, and I'm not going to worry about what it is. We can find out the value. And that's going to be equal to 34.2 minus VI. Because over here, this canceled. Now, and again, I do not mean to condescend to anyone. If what I'm saying is so obvious to you, then that's fine, but I know it's not to everybody. When you are trying to find an unknown in math, this is VI, it's an unknown, and it happens to be a negative thing, there's a negative in front of it, I think keeping it where it is in the equation is a bad move. You add that thing to both sides to make it positive on the left. But at this level, I would never write plus VI plus VI. I would simply, it's called transposition. I would transpose this term to the other side where it becomes positive. And I got to get rid of the 3.01 minus the times the 3.95, so I subtract it. I transpose it to the other side where it becomes negative. And now I can calculate my answer. And I know what happens in this lesson. This is one where if it bleeds into tomorrow's lesson, that's fine. I expect that to happen. This is the foundation of so much in this course in Physics 30. So I'm not going fast here. Let's take 34.2 and subtract 3.01 multiplied by 3.95. Can everybody do the calculation as well and confirm that you get 22.3 meters per second? Okay. So it started off at approximately 22.3. Let's talk about the bane of students' existence in Science 10, which is significant figures. We don't really need to worry about it in exam situations. You would be told how many digits to use. But basically, in this case, if you have 3 digits, 3 digits, and 3 digits, if everything you used had 3 digits, that means everything you used had 3 pieces of information. Your answer should reflect that and have 3 pieces of information. So we're going to write 22.3. And that's our answer. Now, any questions with that? Okay. Here's where you need to arrive at. And some of you may be here right now. You may be capable of this. You need to be able to, and I'm going to leave the vector symbols out of it to make it visually more pleasing. You need to be able to rearrange this for VI. it is preferable for a number of different reasons for you not to put numbers in first and then rearrange. If you can't handle what I'm about to show you now, you need to build that skill, because there are going to be physics problems that you can't solve by putting the numbers in first. There are going to be physics problems that, believe it or not, you have to rearrange things first. Otherwise, you can't get there. So, how do we get there? Well, again, you say, well, I don't want fractions, so I'm going to multiply both sides by t. And when I do that, I get AT. It's just written usually as A followed by T rather than TA, equals VF minus VI. And then you say, well, I want the VI to be positive, so I move it over to the left. The VF stays where it is, and I subtract the AT. To me, and I hope to you after you try this a few times, this is cleaner. I know the initial velocity is the final velocity minus AT. So I go final velocity minus A times t. I don't have to rearrange with a bunch of numbers, which is a little awkward at times. So I hope everybody sees that that is what we did here. That VI was VF minus AT. I mean, the A and the T here are backwards. I put the T first and then the A, but it's the same thing. All right, let's try example 2 now. A large steel ball is dropped from a height of 4 meters per second above the floor. Is dropped from a height of 4 meters above the floor and accelerates towards the floor at 9.8 meters per second squared. In Alberta, in this location, in and around the Edmonton area, that's the acceleration due to gravity. And that is on your formula sheet. From here on in, anytime you have a question that says an object is dropped or an object is in the air, that's the downward acceleration. Okay? If you go to Calgary, it's about 9.80. Because Calgary has a higher elevation, you're further away from the center of the Earth, there's less gravitational attraction. If you go to Mexico City, where I think the 1960 Olympics were, the acceleration due to gravity might be 9.8 something, which is why a lot of records were broken in those Olympics, because people could jump further and higher. What will the velocity of the ball be when it strikes the floor? So we're going to make a list of things that we know. Here I am going to drop the vectors. This is not easy. Physics is not easy. Everything we're learning in this unit has subtleties to it. This would be an incorrect statement. This would be correct. That if the ball goes from some point above the floor to the floor, its displacement is negative. But we don't need to do that here. We can just say the acceleration is towards the floor, the distance traveled is towards the floor, everything is towards the floor, so we're not going to worry about directions. The acceleration is 9.81 meters per second squared. We're trying to find VF. We're trying to find the final speed, and then we can say as an answer, the final velocity is that number downward. But I've told you that you need 3 things to find a fourth, and I only have 2 things that I know. What else do I know?
Your initial velocity?
Which is what?
0.
0. When you drop an object, the initial time, when the time starts ticking, when the clock starts ticking, is that instant when you let go of it. And at that instant, it's not moving. So VI is 0. So now your job is to go to these formulas and find the formula that we would use under these conditions. And again, I know which formula because I just have experience. But students sometimes need to be reminded, since the time is not given and we're not asked to find the time, you can't use a formula with time. So it's going to be the VF squared equals VI squared plus 2AD. Oh, I should have mentioned this earlier. I don't know why it slipped my mind. This formula, although we don't need the vectors here at all, this formula has vector symbols above A and D. It does not have them above the VI and the VF intentionally. Okay? There's no vector symbols above VI and VF. I'm like my mother pointing at you. There's no vector symbols above VI and VF because when you square it, if it were negative, it becomes positive anyway, so it's useless. Okay, that's why. Anyway, we're going to put the numbers in. This will be easy. VF squared, we're not even going to have to rearrange anything, will be equal to 2AD. I'm dropping the vector symbols because I'm telling you it's unimportant. Why did that formula all of a sudden become simpler without even putting numbers in?
VI is 0.
Right, VI is 0, so 0 squared is, you had said that? Yeah, VI is 0, so when I put 0 in for VI, I'll get nothing. So here's the formula. I mean, we can put the numbers in now, or if you like. We can put root 2AD. Now, I know Gabrielle has taken Math 20. She's in Math 30 right now, and somebody else might have taken Math 20. There is, Gabrielle, this idea, we don't want to go there here yet. We will talk about that later, and I will have to explain to everybody else what that's about. It is useful, but not in this question. So we can put the numbers in. It's a pretty easy question, actually. VF, well, the speed, anyway, will be equal to the square root of 2 times 9.81 times 4. Again, I choose, even pretty much throughout the whole course, to say don't worry about putting the units in. Unless it's a written question where you have to show all your work. Just a matter of calculating this now. So do this. Don't forget to take the square root. Whoops. So about 8 point, what do we want for significant figures? Well, there's only 2 digits in the displacement, so we go with the lower number. We want to record this to 2 digits, so I'm going to put 8.9. Meters per second. I mean, the true answer to the question is 8.9 meters per second down, because it did say what is the velocity, right? That one's a little easier. Any questions with number 2? How long does it take for a large box drop from a height of 10 meters to reach the ground? So when you first look at this question, it really doesn't look like there's much information. It travels 10 meters. And again, because everything is downward, I guess what I'm really doing is I'm saying down is positive. Now, if the box were thrown up, it's going to go up and then down. Then we would have to be careful about vectors and directions. But everything is in the same direction, so who cares about positives and negatives? We got to know something else. If you're asked to find the time from that, we need to know 2 more things. Well, we know VI is 0 because it's dropped. Yep.
Acceleration.
Right. Because presumably it doesn't say it's happening on the surface of the sun. Well, there'd be nothing left if it were on the surface of the sun. But it doesn't say it's happening on the moon. We assume it's happening on Earth. So the acceleration is that 9.81 meters per second squared. And VI is 0. So your job right now is to determine which equation we're going to use. Looking at the list of things, we do not have VF, so you cannot use an equation that has VF in it. And this is the equation we're going to use. Just give some thought to what I just wrote. This equation is not on your formula sheet. This equation is on your formula sheet. But if VI is 0, it doesn't matter what T is, because 0 times the time will be 0. You won't have a formula there. You won't have a term there. Just so you know, everybody, if VI is not 0, and you're trying to solve this equation for t, you can't do it unless you use the quadratic formula. That's the only way you could find t in this formula. But in this case, that VIT goes away. And for those of you that heard quadratic formula, it's something you would learn in Math 20. So I would like to rearrange this first. And as time goes on, I'm going to maybe increase my standards to you. I'm not going to write down and explain everything. I will explain what happened here. I don't like fractions, so I multiplied both sides by 2. And I get 2d equals at squared. So if you think about that, I get 2d equals at squared by multiplying both sides of this equation by 2. At this level, everybody, for goodness sake, you don't have to do this. You do not have to, nor do I think you want to show that. You're just multiplying both sides by 2. It's child's play. And then, from there, I say, well, I want to get t by itself, so I would have to divide both sides by a, and then I can take the square root. So again, you could put the numbers in to begin with. I just prefer not to in this case. So I'm going to get 2 times, was it 10 meters? Times 10 divided by 9.81. And I have to take the square root of that to get t. And by my calculation, don't ask me why I know this, it's about 1.4. I think we want 2 digits. So rounded to 2 digits would mean, in this case, 1.4 seconds. Car accelerates uniformly from an initial speed of 45 kilometers per hour. What's the final speed if it travels 300 meters in 15 seconds? So let's write down what we know. The initial speed is 45 kilometers per hour. The displacement is 300 meters. And it does so in 15 seconds. So let's find the formula that we want to use in order to find VF. And this is the formula. Be very careful here. A common mistake, and you might find yourself making it, I might find myself making it, is that this formula in the top right that we want to use has a VF and a VI, and this formula over here has a VF and a VI, but in one of the formulas you're subtracting and the other you're adding. And sometimes I see students write down this formula that I've highlighted and they put minus instead. So that's the formula that we're going to use, which really is this. Wow. Let's do this 2 ways. Let's do it by putting the numbers in first, and then I'll talk about rearranging it, okay? This is one where I think the last couple of examples, I didn't put the numbers in first because the rearrangement was so basic. The rearrangement here is not basic. So I'm going to put the numbers in. This is 300 is equal to VF, which we don't know, plus VI, which I'll put in a second, over 2 times 15. Now, why did I not write in VI? There's a reason. Right. I have to work in consistent units. If I have meters and seconds, which we call a standard unit, pair, we want to use meters per second for velocity or speed. So a little detour here, and again, I'm not trying to rush through anything. It's very laid back today. Does anybody remember how to convert kilometers per hour to meters per second?
Divide by 3.6.
Perfect. Well, just a second. Divide by 3.6. Let's do this. Okay, let's do this. Take your calculator and divide by 3.6. It's right, but some people will say multiply by 3.6. They'll remember that 3.6 and they'll, do I multiply or do I divide? And I want to talk about the reasonableness of this answer. So we're getting 12.5 meters per second. Although I'm not rushing, I don't want to spend time explaining why this works. I can talk about it later. Okay. Does this seem reasonable? We have all been in a vehicle traveling at 45 kilometers per hour. That means you're speeding going through a school zone, but you're not going really fast, okay? Or you're just under the speed limit in a residential area. Does 12.5 meters every second ring true to you? Does that seem reasonable? Sure. 12.5 meters, I don't want to get out a meter stick, is probably the width of this room, give or take. I mean, maybe closer to 15, but if I start laying down meter sticks, I'll probably get to 10 or 12 over here somewhere, okay? So this is the speed. Now what some people will do, and I get it, because there's a lot that we're going to have to remember, is they will say, well, yeah, it's 3 point. You know, I'm pretty sure it's times. I'm pretty sure it's times. And what do they get? Let's see. I mean, it's not. This is wrong. Okay. You're getting 162 meters per second. Now, I judge hundreds of meters by football field lengths. Football field is basically 100 meters, basically. Okay, not exactly. It's in yards and there's different issues. This is 1.6 football fields per second. Just imagine Norm Brown Field out there, and you even double that football field and talk about two lengths. When you're driving at 45 kilometers per hour, you're not covering that distance in 1 second. It doesn't seem reasonable, right? So we have to put in 12.5 here. So how do we rearrange this? Well, there's a fraction. We would say to ourselves, I'm going to multiply both sides of this by 2. And what happens on the right side is this, and you're left with 600 equals VF plus 12.5 times 15. And there are math teachers, myself included, in a certain question?
Why would you divide by 15 first?
We're about to.
Okay.
We're about to. I mean, if I were talking to a grade 11 math student in math class a month from now, I'd say, so we're going to have to multiply by 2 and divide by 15. Okay? Or we're going to have to divide by 7.5. But I'm just going in baby steps here. Okay? So if you were in grade 9 or 10, maybe your math teacher would say, now you multiply that 15 through. Don't do that, because you're making the numbers bigger. The bottom line is you're trying to get inside of this set of brackets, and that set of brackets is being multiplied by 15. So as Ephraim said, we're going to have to divide by 15 at some point. And when I divide both sides by 15, did you say that because you would have divided by 15 first? Or you would have just done them both at the same time?
I mean, if you were doing them step by step, I would definitely do 15 first.
Okay, so, but it turns out, and that's fine, I just want to point out to everybody, BEDMAS says multiplication and division happen before the other stuff. So when we divide to unwrap this equation, you can either divide by the 15 first and then multiply by the 2, or multiply by the 2 and then divide by the 15. You could take 15 divided by 2 and get 7.5 and divide by 7.5. You know, and what I would say to you are the details of that is unimportant. What is important, and you will want to check my arithmetic here, is that you're going to end up with the number 40 over there. Is that right? Okay. 600 divided by 15 is 40, so we get 40 equals VF plus 12.5. How you arrive at this point is entirely up to you. So when I go at this point in the course, step by step and baby steps, it's to make sure everybody has a successful path to the answer. You could just do it all on your calculator, really, if you know what's going on here. So now I subtract 12.5 from both sides, which I'm not going to show, and I get VF equals, I want to say 27.5 meters per second. Yes? Okay. If I have D equals VF plus VI over 2 times T, and I want to find out the value of VF, then here's what I would have done. I need to multiply both sides by 2 and divide both sides by T. Or divide both sides by T and multiply both sides by 2. So I would get 2D over T equals VF plus VI. And then I can subtract VI. So again, in the algebraic approach, where we rearrange the equation first, you're going to get VF equals 2D over T minus VI. And a very quick note here. And if this doesn't bother you, you're not getting what I'm saying because you go, well, who would do that? People think differently, okay? Some people are bothered by the fact that the VF is on the right here, and I'm subtracting VI from both sides. So I'm getting 2D over T minus VI equals VF, but I wrote it backwards. It doesn't matter. If 2D over T minus VI is VF, then VF is 2D over T minus VI. Okay? And you could put the numbers in. That's it, right? It's the final example. I do not want you to do all 13. By my count, and they keep switching the bell times on me, you do not have much time, according to what happened this morning in period 1. You have like 3 minutes before the bell rings. Here's what I want you to do. You're going to have more of these to practice tomorrow. For homework, I want you to start with question 1 and do 3 or 4. Okay? Just warm up your brain to this idea of picking the right formula, putting the numbers in, and getting the answer. Quite frankly, I don't care about what you write. At this point in time, I care that you can get the right answer, which is a refreshing idea. I don't care about work or anything. Can you get the right answer? And that's your homework. Do 3 or 4 of them. Okay?